You know, most programming languages have a special keyword to help you declare a global constant variable, but not Java. In Java, we have to use two keywords. We have to string together static and final in order to make the equivalent of a global constant. And, you know, that combination of static and final tends to confuse new Java developers. And I'll be honest with you, it tends to confuse advanced Java developers as well, which is why I put together this simple little example to show you the difference between the keyword static and final and show you what it means when you put the two of those keywords together. Hi, I'm Cameron McKenzie. I'm the editor-in-chief over at theserverside.com. And I have to be one of the world's biggest Java advocates. And one of the questions I often get is, why is a constant in Java static and final? And that is what I'm going to explain to you right now. So to really emphasize the difference between static and final and demonstrate why we use static and final together for global variables in Java, I put together this little example that uses the prototypical bank account example. As you can see, I've got that class account and it's got three variables, one of which is called account ID, which is final, one of which is called rate, which represents the interest rate, which is static, and then finally an overdraft limit, OD limit, which is both static and final. Now, the reason why the account ID is final is because that variable is constant. Once a bank account ID is assigned to account, it can never change. Once I open up a bank account and I get my bank account ID, that bank account ID follows me forever. But my account ID is different from your account ID. So every instance of the account class can have an account ID with a different value. But once that value is assigned, it can't change. So I can emphasize that in code right here. I can say account first equals new account, 1, 2, 3. And I could say account second equals new account, 3, 4, 5. And then I can do system.out.println account.account ID. That will print out the ID of the first account. A little copy and paste there because I'm lazy, and that would be first, that would be second, not account, first and second. And now when I run this code, you can see that the output is 1, 2, 3, and 3, 4, 5. The first account has an ID of 1, 2, 3. The second has a different number, it's 3, 4, 5, but both of those values can't change. If I was to say first dot account ID equals 7, 8, 9, and tried to run this code, well, I'd be in a world of hurt. It would say, cannot do that. You cannot assign a value to a final variable. Compilation failed. So both of those accounts have a separate value, but once the value is assigned, it can't change. Now contrast that against a static variable. A static variable can change, but every instance of the class shares the same value. So over here, if I say first account dot rate equals 2.5, and then I system.out.println first.rate, well, you'll see that the rate gets printed out as 2.5. If I come over here and I print out second.rate, well, before the change, the second instance has a value of 1.5, but after the change on that instance named first, well, that second instance also gets their value changed to 2.5. So the idea of a static variable is that it's a variable that every single instance of the class shares. So if the interest rate changes from 1.5% to 2.5%, that gets applied to every single bank account we have, whether we have 2 bank accounts or 2,000 bank accounts. And behind the scenes, it's actually implemented through the fact that every single bank account instance points at the same memory location. So if the memory location starts off at 1.5 and one of the accounts changes it to 2.5, well, it's a shared memory location. So every single account points to that same value. You change it for one, you change it for all of them. In fact, here I've said first.rate to change the value. That would actually get you a warning if you did that in a clip. You really should just actually say account.rate to really emphasize the fact that, well, that rate actually applies to every single bank account, not just one instance. So I run the code and it's going to like that just a little bit more. So a final variable is one that can't change after the value has been assigned, but every instance can have a different value. A static variable is one that's shared by every instance of the class. So if you have 1,000 instances of your class, there's only one spot in memory where that value is assigned. If anybody changes that one spot, it changes for everybody because everybody's pointing at that same location. Now with static final, you get a combination of the two. You get a variable that can't change, and it's stored in one single memory location. So that's the overdraft limit, right? So if I try and print out the overdraft limit right here, second.overdraft limit, well, that is going to print out 1,000. And if I try and print that out for the first as well, well, that's going to print out 1,000 too. So I'm going to run that code. You can see that the overdraft limit for that first instance is 1,000. The overdraft limit for the second instance is 1,000. However, if I try and change that at all for any of them, first.od limit equals 20, or even just account.od limit equals 50, both of those lines of code are going to cause a lot of trouble because now I'm trying to change the value of a static final variable. And here it's not actually just the fact that it's static, it's the fact that it's final. I've created a constant variable. So in Java, why do we use static and final for global variables? So first of all, it's final because final means once the value is assigned, it can't change. The reason why we use static is because the static keyword says that the value will be assigned one memory location no matter how many instances of the classes are created. So it becomes very, very efficient. Every single instance of the class, whether you have 2, 2,000, or 20,000, will all be looking at that same point in memory, that same location in memory. In this case, it's an int, so that would be 32 bits in size. That's very small. If you had 20,000 instances of this class and the variable wasn't static, well, that would be 20,000 times 32 bits, which all of a sudden starts consuming a lot of memory. So there you go. That is why when we declare global constants in Java, we combine those two keywords, static, so that it applies to every instance of the class, and final, so it won't change. So there you go. Now, if you enjoyed that tutorial, why don't you head over to theserverside.com. We've got lots of other great tutorials on Java, on DevOps, on Git, on Scrum. If you're interested in my personal antics, you can always follow me on Twitter at CameronMCNZ. I've also got a newsletter in the description there. I'm doing a lot of work these days with Mojo. It's a new programming language that looks a lot like Java, and it's poised to replace Python. If you're a Java developer, it really behooves you to get on top of what's going on with this Mojo programming language, because if you don't get ahead of it, you're going to get behind in a hurry. So sign up for my newsletter. And of course, I've got a couple of books too. You can see Hibernate Made Easy in the background and Pickering is Springfield about The Simpsons. I'm also working with a young freelancer named Darcy DeClute, who wrote a Scrum Master certification guide, which a lot of people are using to score 100% on the Scrum Master certification exam. So if you're interested in getting Scrum Master certified, check that out. And finally, if you're watching this video on YouTube, why don't you subscribe on the YouTube?